Hello students, you are welcome to Prepclass Tutors, and today we will continue with our WAEC questions on chemistry. You know, we've been solving some past questions on chemistry. I think we've solved questions number 1 to 15. So today we'll be looking at questions 16 to 20. My name still remains Mr. Chima. I'm your Prepclass tutor on chemistry. Now, first and foremost, do not forget to always try to subscribe to our YouTube channel and like our YouTube channel with all our videos, because we will continue, as we have always done, to provide for you educational and very entertaining videos, and not only chemistry but on every subject which you are interested in learning. Okay, now let us continue. So we are going to, like I said, we are going to be continuing with our questions 16 to 20. Okay, quickly let us start. Now, question number 16. This one says, which of the following pairs of elements has the greatest difference in electronegativity? Which of the following pairs of elements has the greatest difference in electronegativity? First of all, what is electronegativity? Electronegativity is the power of an atom of an element to attract electrons. The power of an atom of an element to attract electrons. Now, hearing this, the power of an atom of an element to attract electrons, that simply tells you that electronegativity should be ascribed to what? Electronegative elements, which are usually basically non-metals. So non-metallic elements usually have high electronegative values. And that is why if you look at these options, you will see that sodium is being paired with non-metals. And if you can remember in our last class, I listed all these non-metals here as what? Halogens. Fluorine, chlorine, bromine, and iodine. They are very electronegative element. That's why sodium is paired with each of them. So you will see that from here, the most electronegative elements, as you see that I explained in our last class, is what? Fluorine. So I said that amongst the halogens listed, fluorine is the most electronegative. And because fluorine is the most electronegative, the electronegativity variation between sodium and fluorine will be higher than the remaining three, because fluorine is the most electronegative. So because of that, the correct option to this question is option A. So the pairs of elements that will have the highest difference in electronegativity is sodium, which will have a low electronegative value because it's a very strong metal or a highly electropositive metal, and fluorine, which will have a high electronegative value because it is a highly electronegative non-metal, or I can say a highly electronegative element. I believe you understand this question. It's very simple. Okay, let us look at the next question. Question number 17. This one says, a factor that is considered most important when citing a chemical industry is, a factor that is considered most important when citing a chemical industry is, A, is it nearness to other industries establishment? B, is it nearness to raw materials? C, is it favorable climatic conditions? And D, is it availability of storage facilities? Now, if you look at this question critically, you will see that even with common sense, we should know that the most important among all these characters listed is nearness to raw material. Availability of raw material at the right time is the most important factor for citing a chemical industry. Because the raw material that is used to produce the finished goods, without the raw material, you cannot even start any process. Without the raw material, there will be no availability of products. So, raw material is like the bedrock of any industry, because without the raw material, nothing will happen. So the raw material must be available at the right time, and because of that, nearness to raw material is the most important. It must be available at the right time, and it must be very close to the chemical industry as possible. So the correct option to this question is nearness to raw material. This one is the most important. It's not that other ones are not important. Favorable climatic conditions, availability, of course there should be storage facility, but the most important is availability and nearness to raw materials. Question number 18. The boiling point of pentane is higher than that of propane because A. Is it because of the carbon-carbon single bonds are stronger than the carbon-hydrogen bonds? B. Is it because pentane has more covalent bonds to break? C. Is it because pentane does not burn easily as propane? Or D. Is it the intermolecular forces in pentane are stronger than those of propane? If you look at this question, what do you think will be the correct answer? Now, look at what I said here. I said, as the length of the alkene chain increases, the boiling point increases because more carbon-carbon chain molecules are added up, thereby increase in number and the strength of the covalent bond. What does that mean? You know that pentane is C5H12, while propane is C3H8. Now, pentane has more carbon-carbon atoms than that of propane. So normally, increase in carbon-carbon atoms usually result to an increase in boiling points. So as the carbon-carbon atoms increases, as we go from one alkane to another, there is usually an increase in boiling point. And there is an increase in boiling point because that carbon-carbon atom tends to bring about the increase in covalent bond. I believe you understand me. So the more the carbon-carbon bonds, the more the carbon chains, and the stronger and the number of covalent bonds. So the correct answer to that question is because pentane has more covalent bonds to break. Because it has 5 carbon atoms, whereas propane has 3 carbon atoms. So because pentane has 5 carbon atoms, it has more covalent bond to break than propane. So the correct answer is B. Number 19. Which of the following solids would not decompose on heating? Which of the following solids will not decompose on heating? First option, is it ammonium chloride? Is it Lead-2-triazonitrate 5? Is it potassium triazocarbonate 4? Is it sodium hydrogen triazocarbonate 4? Which of the following solids would not decompose on heating? Now, you must remember this, that the triazocarbonate 4, the reactive group of elements like sodium and potassium, do not decompose on heating. The triazocarbonate 4, sodium and potassium, do not decompose on heating. Only the hydrogen triazocarbonate 4 decompose on heating to give the required triazocarbonate 4, carbon 4 oxide, and water. So you can see this equation I gave you here. Can you see the equation I gave you here? 2KHCO3 will decompose on heat to give the triazocarbonate 4, water, and carbon 4 oxide. Same thing happens with sodium triazocarbonate 4. So their triazocarbonate 4 will not decompose, but their hydrogen triazocarbonate 4 actually decompose on heating. So if you look at this option, you should know that potassium triazocarbonate 4 will never decompose on heating, but sodium hydrogen triazocarbonate 4 will decompose on heating. All these other ones, like ammonium chloride, of course, will decompose to give ammonia and hydrogen chloride, and Lead-2-triazonitrate 5 will decompose to give Lead-2 oxide, triazonitrate 5, nitrogen 4 oxide, and oxygen. But it is only potassium triazocarbonate 4 that will resist decomposing on heating. But this hydrogen triazocarbonate 4 will not decompose on heating. So the correct option to this question is option C, potassium triazocarbonate 4. Number 20, and the last for today. The following molecules have double covalent bonds between two atoms except The following molecules have double covalent bonds between two atoms except A is the oxygen, B is the carbon dioxide, C is the ethene, D is the water. So which of these molecules do you think will have a single covalent bond? Because I said that all of them have a double covalent bond except one. That means one has maybe either a singlet or a triple covalent bond. Now the first thing you have to do is to try to draw the structure of these molecules. Try to draw the structure. You can see oxygen molecule. You can see there's a double bond in between the two oxygen atoms. They form oxygen molecule O2. There's a double bond. Carbon dioxide. You can see there's a double bond between the carbon and each of the oxygen atoms. There's a double bond here. There's a double bond here. So there's a double bond between the carbon and each of the oxygen atoms. You can see clearly. There's a double bond here. There's another double bond here. Ethene. You can see that there's a double bond between the carbon-carbon linkage. You can see the double bond here. The unsaturated nature of ethene. You can see the double bond here. And the last one, water. There's only a single bond between the oxygen and each of the hydrogen atoms. Only a single bond. So the correct option is what? Water. Only water does not have a double covalent bond. And that is why the correct option to this is option D, water. Okay, students, we are going to stop there for today. Do not forget to always like us, like I said before, by subscribing to our YouTube channel. And you can always join us on WhatsApp to get more entertaining and educational videos on not only chemistry, but on every other subject which you are interested in learning. Once again, my name is Mr. Chima, your Prepclass tutor on chemistry, and I'm going to see you next time on chemistry. Bye, and do take care of yourself.